Hello everyone, welcome to our second video in this series. So remember to check the description for the first video in this series, all right? So what we're going to look on is solving equation, but we'll focus in on case 2 that deals with equation containing subtraction, right? So let's look at some example. So example 1, we're given a minus 3 is equal to 6. Again, the objective is to get the letter by itself. So if you notice here, we have a minus 3 beside this a. So we can transfer this minus 3 over to where 6 is. How can we do that? We can do that by doing the opposite of subtracting 3, which is to add 3. But we must remember, we must add it to both sides. So step 1, add 3 to both sides. How would you state this in your book? You would state this as a minus 3 plus 3 equals 6 plus 3. As you'll notice, to the original problem, all I have done is just to add 3 to both sides. At this stage, what we are going to do is to simplify. So note that when we simplify this, 3 minus 3 plus 3, that is just 0. And 0 plus a will give us a. And 6 plus 3 will give us 9. So therefore, our solution is going to be a equal 9. Now you can always check your solution. We just found out that a is equal to 9. So in the original problem, if you replace a with 9, 9 minus 3 will give us 6. So therefore, our solution is correct. Let's look at a second example. We have b minus 2 is equal to 7. Again, going to do the same idea. We want to transfer this minus 2 over to where 7 is. We can do that by adding 2 to both sides. How would you state this? You would state this as b minus 2 plus 2 is equal to 7 plus 2. At this stage, we are going to simplify. Note that minus 2 plus 2 is 0. So 0 plus b will give us b. And 7 plus 2 will give us 9. So therefore, we know that b is equal to 9. If we do a quick check, if we replace b in the original problem with 9, then 9 minus 2 is 7. So therefore, our solution is correct. Now to example 3, we're given 8 equal p minus 5. Note now that the variable is now on the right. Does the principle change? No, it does not. So note here that we have this minus 5 beside p, but we want to isolate p by itself. So we can do the opposite of subtracting 5, which is to add 5 to both sides. How would you state this? You would state this as 8 plus 5 equal p minus 5 plus 5. As you can see here and compare the original problem, all I have done is just to add 5 to both sides, as I have color coded here. In the next step, you're just going to simplify, and that will give you a solution. So note here that 8 plus 5 will give us 13. Minus 5 plus 5 is 0, and 0 plus p will give us p. So therefore, 13 is equal to p. But we can always rewrite this and put our variable on the left-hand side. So p is equal to 13. Let's look at our final example, which is 5 is equal to q minus 8. Now we want q by itself, right? Because that's what we are trying to solve for. So what we are going to do, we know that we have a minus 8 here. We want to transfer it over to where 5 is. So we're going to just add 8 to both sides. How would you state this? It would be 5 plus 8 is equal to q minus 8 plus 8. Then what are you going to do? You're going to simplify. After you simplify, that will give you your solution. So note here that 5 plus 8 is just 13. And minus 8 plus 8 is 0. And 0 plus q will give us q. And you can always restate your solution so that the variable is on the left. So therefore, q is equal to 30. Now that you have a clear understanding of how to deal with problems that contain subtraction, here are some questions for you to try. Thank you for watching and do enjoy the rest of your day.